Following on from the previous video, we got to this stage here where the volume of that solid is given by this. So now it's just a matter of evaluating this integral. So looking at the inner integral, integrate this with respect to x. That will then just give you x from 0 to 4 minus y, from 0 to 4 minus y. So now put this into here, and then take away, put this into here. That will then give us this thing here. So now now integrate this again. So looking at the y integral, integrate this. That will give you 4y. Integrate this, it will give you y squared minus 2. Y minus y squared over 2, and you're integrating from 0 to this thing here, from 0 to this thing here. So now it's just a matter of us putting this into here. That will then give us this, and then put this into here. That would be yeah. So when you square this, it would just be this thing here, and then when you put 0 in here, this thing disappears, this thing disappears, giving you this thing here. So now now tidy this up. So this is 8, and this is 2z squared. The hard part is in integrating this. So we've done this before. To integrate this, let's ignore everything else. Okay, so let's just concentrate on this thing here. Remember, the 4 is on the outside. We're not concerned with the 4. We're just looking at this bit here, because this bit here is hard to integrate. So when you integrate this, you would have to use trigonometric integration, which we've done in the past, and I'm expecting you to be able to do this. So to integrate this, let me just explain this diagram here. To integrate this, you would then have to create a triangle in such a way that this thing will be true. So if you make this to be 2z, and if you make this to be 4, then the adjacent will have no choice but to be root 16 minus 4z squared, which is this thing here. Okay, so if you let sine theta, so this is sine here. So basically now I'm just trying to show you how you can integrate this. We've done this in calculus 2, so I'm just showing you how to integrate this. So sine theta equals 2z over 4, which is this thing here, and then differentiate both sides. That will then give you dz equals this thing here. So we can now put this into the dz, and then this complicated thing here is really cos theta over 4. So whether looking at this diagram here, cos the angle equals root 16 minus 4z squared over 4. So times both sides by 4. So you see this square root thing is really 4 cos theta. So that square root thing is really 4 cos theta, and this dz thing is this thing here. So we can put this into the dz, giving you this. So now drag the 8 out, and then it's just a matter of integrating cos squared. We've done cos squared before. If you can't remember how to integrate this, then look it up. When you integrate this, it will then give you this thing here. If you can't remember it, we've done this before. If you can't remember it, look it up. So so now I want to translate this block. Well, this block here is really a block of 2 times a block of sine times a block of cos. So so this block here, this times this will then give us this. This times this will then give us this. I now want to translate this double angle here, double angle, where I can then put this into here. So this 2 here would multiply with this 4 to give us this 8 here. Well, it will then take us to here. So now we don't want the answer in terms of theta, we want it in terms of z. So so going back to here, you can see theta is inverse sine z over 2. So it's inverse sine z over 2. So so this theta here is this block here. You've got your 8. Well, sine theta is this thing here, z over 2. Z over 2. And then cos the angle. Well, what's cos? Cos is this thing here. Cos the angle is adjacent over hypotenuse. Is the adjacent over hypotenuse. So it's just a matter of tidying this up. So when you tidy this up, to integrate just this bit here, it gives us this ugly thing here. Okay, so we've done this before, and I'm expecting you to know this. So if you integrate this, it will give you this. So going back to earlier, we got to this stage here. We need to integrate this hard part here. So hang on. Now that we know how to integrate this, we can just replace. Well, when you integrate this, it will then give you this whole thing here. And remember, this 4 here is on the outside. When you integrate 8, it will be 8z. When you integrate this, it will then give you this. And you're doing it from 0 to 2. You're doing it from 0 to 2. So we are currently here. So now it's just a matter of us putting 2 into the z. So that would be inverse sine 2 over 2 is 1. What's the inverse sine of 1? Well, if you look at the sine graph, sine of 1 is right here. So the inverse of it must be pi over 2. So this block here is actually pi over 2. And then you've got your 4 here. And then let me think. And then when you put 2 into here, 2 squared will be 4. 4 times 4 would be 16. So this block here would be 0, making the whole lot here to be 0. And when you put 2 into here, it will give you 16. And when you put 2 into here, 8 times 2 would be this divided by 3. And then when you put 0 into here, everything would be 0. So the final volume is given by this. Okay, that's your final answer.